We welcome you to our project demonstration video. As a part of Analog Design Contest India, as a part of Phase 1B, we are now presenting the video demonstration of our project. We are a team from Coimbatore Institute of Technology, team number 330, and our project is on physiological stress monitoring and reporting system for industries. First of all, I would like to thank the TA Analog Design Contest organizers for providing us a great chance to work on our projects, and I would like to thank our college management, our HOD Dr. A. Rajeshwari ma'am and Dr. Suma Maheshwari ma'am, our tutor, for their support, and I'm very happy to say that we are receiving good support from the Texas Instruments throughout this phase. Psychological stress has become most common thing in day-to-day life these days, which is not a good sign for a society. So our project mainly focuses on detecting the psychological stress of a person. The main reason for the psychological stress is the workload that a person have in industries. So it is the quality of the time that they work matters than the quantity of time. Under a stressful condition, if any person works, he cannot give his 100% output. So our main aim is to create a monitoring and reporting system so that their immediate seniors can know about their stress condition, and they can provide them the ample time gap to relax so that they can work more efficiently. Basically, there are two types of nervous system in our body: sympathetic nervous system and parasympathetic nervous system. When a human is under stress or psychological stress, what happens is his sympathetic nervous system gets activated. It comes into action, and then it triggers the sweat glands in the body, and then the sweat gland gets activated, and it will start secreting the sweats. So because of the sweats, the skin resistance of the body gradually decreases and the mental stress increases. This is the major thing that we are going to use in our project. And another thing is, under stressful condition, the heartbeat increases. The number of times the heart beats per second increases. So these are all the two main factors that we are going to use, and there are a lot of other factors caused by mental stress, like pupil dilation, thermoregulation in the body, I think. But in our project, we are going to use only the galvanic skin resistance variation and the heart rate variation. There are two main sensor modules in our project. The first one is galvanic skin resistance sensor. It consists of a skin electrode, a wearable skin electrode, in which we will be connecting it in the hands so that we can get the skin resistance. This is its following circuitry. It is nothing but another resistor in series, so that we can connect the skin resistance and another resistance in series, and it acts as a voltage divider. Under stressed conditions, the skin resistance will be very low in terms of kilo ohms, and then under normal conditions, the skin resistance will be as high as 3 to 4 mega ohms. So we are using 1 mega ohm resistor in series and act as a voltage divider. And then the output, we are amplifying the output using TL082 op amps. And then the output impedance of the circuit is very high, so we are using a voltage buffer to reduce the output impedance. The second main module of our project is photoplethysmography sensor for measuring the heart rate. Here we are using transmissive photoplethysmography technique. There are two types of technique basically, transmissive and receptive. We are using transmittive photoplethysmography, and what we do here is we are passing a IR ray through the fingers and then receive it on the other side of the finger using a IR detector. So what happens is, when the heart beats, the blood volume concentration in the finger increases, and as time goes on, the blood volume decreases till the next pump. Again at the next pump, the blood volume pulse increases. So when the finger is kept as a obstruction between the IR transmitter and the receiver receives a pattern similar to the heartbeat. We are using here a 940 nanometer. This is our circuit. This is a outside protection to avoid external noise from the light. We are using a 940 nanometer IR LED and IR detector. Basically, the heart beats around a maximum of normally the heartbeat is 70 beats per second, and it can reach a maximum of 100 or 110. So the frequency is a maximum of 2 hertz and a minimum of 40 beats per second. So we are filtering the output to avoid unnecessary noises and optical noises. We are using a filter with a lower cutoff frequency of 0.7 hertz and a higher cutoff frequency of 2.34 hertz, so that we can receive a signal that we intend to receive, and then we are giving the output to the MCU. Now you can see the heartbeat pattern in the it is a Stellaris EKS evaluation kit. Now in the display you can see the output of PPG sensor. It is the heartbeat pattern. It is not it is not just the mental pressure that affects the heart rate and skin resistance. There are a lot of other factors that also affect these parameters. For example, a short sprint can increase your heartbeat very high and can make you very sweaty. This doesn't mean that you are under a psychological stress. So we need to classify the patterns between the increase in the heart rate and skin resistance variation because of other factors apart from the psychological stress. So we need a clear mathematical model to classify these patterns. So we are to obtain the mathematical model, we are bringing the sensor outputs to the MATLAB. This is the MATLAB code we have written to bring the data into MATLAB. And now in the screen you can see two waveforms. One is the PPG waveform and the other one is the skin resistance waveform. You can see the peaks in the PPG data, in the skin resistance.
After obtaining the real-time data, we convert it into mathematical model by using neural networking. We are avoiding thresholding method because it does not involve mathematical model, but it uses a prediction model. In order to train the network, we continuously evaluate the test subjects to psychological test, which contains two sets of questions. One set which is the easy one and the other the complicated one. By conducting the psychological test, we obtain data which consist of stressed and unstressed conditions. The values obtained for our experiment are as follows. The first column consists of the values related to galvanic skin resistance in mega ohms, while the other is the heart rate. First, we construct a neural network which consists of two inputs and two outputs. It has three layers: input, output, and hidden layer. The hidden layer is used in order to for adaptive learning. The values obtained by the psychological test is used to train the network. The data set is given as input to the program. We are using the data set to train the network. The performance of the data set can be analyzed using the neural network toolkits which is provided in MATLAB. The confusion matrix gives the clear view of the training network. Once the network has been trained, we can obtain real-time data and get outputs. The output of the network is from 0 to 1, and a fuzzy logic is used in order to obtain whether the test subject is in stressed or unstressed condition. If there is an exceptional case available, the network automatically adapts itself using backtracking. This is how our project continuously monitors the condition of the test subject and provides us output whether it is he or she is in stress or unstressed condition.